It's always hard to follow Jack at these types of things, so I'll do my best. But first, I just want to thank everybody here. It's been 3 years since I've been to Taiwan, so this is my first trip since the pandemic. And it's really great to see everybody turn out and support SiFive. So first, I just want to thank you. Okay. Legacy efficiency processors are failing the industry. It's a pretty bold statement. But I think everybody would agree ARM's Cortex A53 and A55 processors have been very, very successful. These cores launched a decade ago, 5 years ago, and you see them everywhere. However, ARM's released newer efficiency processors since then, right? They have the ARM Cortex A510, but if you look outside of mobile, you don't really find this processor. So why is that? So if you look at some recent high-profile device launches, so Google just launched their Pixel Watch, this has the Cortex A53. Why not the latest efficiency processor? So we think there's a couple reasons for this, and we'll talk about that over the course of the presentation. But we also think SiFive has the answer to this. We have significant new products that we launched towards the end of last year that we think offer very, very compelling upgrade opportunities for these legacy applications that are running on Cortex A53 and A55 processors. Also, in addition to the performance of these cores and power and area, we also have a number of new features and capabilities that are really leading in the RISC-V space, as we are the first company to bring some of these features to market. And then finally, the SiFive portfolio offers you, the customer, a lot of flexibility. Jack talked about compute density, and we'll talk a little bit about what that means specifically, but we think it gives you, the customer, flexibility in configuring your device with the right performance, the right power, the right profiles, and the right features for your applications and markets to get the most out of the core. So now let's take a look at the SiFive Performance family. So the SiFive Performance family is the leading RISC-V application processor family. We don't have one solution, we have many solutions. As a matter of fact, we launched 4 new processors at the end of last year, and that's what we'll spend this presentation talking about. Performance density leadership. So this is very important. It's more than just cost, and we'll talk about all the possibilities that are enabled with SiFive's performance cores. Again, we're first with the latest RISC-V features and technology. Jack mentioned vectors, but there's a lot more features that are needed for the application processor space, things like virtualization and security. And then it's not all about performance. It's adding smart performance, power efficiency, right? As you see, some of the applications that we're targeting, it's not about absolute performance. And in fact, some of the products that we just launched have a little bit less performance than the previous generation product because we focused on power efficiency. And then finally, and Jack touched on this as well, but there's significant momentum with SiFive right now with key design wins with NASA, with the space computer, Google with our SiFive Intelligence X280, and then the Intel Horse Creek platform that we're realizing with the development board called the HiFi Pro P550. And I think that's important because the products that we launched last year, the performance products, are our second generation out-of-order processor. The first generation, the SiFive Performance P550, has been taped out and realized in silicon. So these cores are real, they're in the market, and you can buy them. So now let's take a look at some of the markets we're targeting with the SiFive Performance family. And let's start with wearables, smartwatches. Here you need significant performance, right? These cores run Android Wear, but they have to be extremely efficient, right? As you're launching your smartwatch applications, your health monitors, these things need to be responsive. And if it takes a while for these applications to launch, it's not a good user experience. But at the same time, you have to be efficient. In addition to that, you also have to have the right software to run on it. And so you see at the bottom here, Android Wear. So Android Wear, we think, is a good first step for the Android ecosystem. So this gives us a way to target consumer devices and application processors running Android, but not as unconstrained as the big mobile environment of full Android. So in the Android Wear environment, it's a much smaller ecosystem, 50 apps, 100 apps that you can target, and this is enough for a consumer product. And we think the products that we're launching will be a good fit for the wearable space. Other consumer markets like DTV, smart speaker, and other smart home devices are also a key market for the SiFive Performance products. In here, this will be a good fit for both our high-end as well as our efficiency processor because we have the right feature sets and capabilities and performance points to address a lot of these markets. In DTV, for example, if you want to have applications that run and target 8K resolutions, very high resolutions, high fidelity, doing audio and video decode, the P670, which is our high-end processor, will be a good fit here. Also, smart cameras. This is an application space that we already play in today. You can go and buy consumer devices from a big tier 1 OEM today that runs SiFive application processors. And we think the new processors that we're launching today are a great upgrade path for that. So things like vector compute are great for smart camera markets where you're doing a lot of image processing. And then, of course, Linux and having great software ecosystem support is also important. And you see RVA22 here, which is very important for this space, and I'll touch more on that in the next couple of slides. Mobile. So I don't think we're targeting mobile per se with this generation of processors, but a lot of the work that's being done now with the cores that we just launched, and especially in the wearable space and Android Wear, sets the foundation for RISC-V to enter the mobile application space, proving that RISC-V can address these markets, that RISC-V has the performance, that RISC-V has the power efficiency, that we have the applications and the feature sets to address these markets. So smartwatch wearables are first step, but ultimately the end goal is to get to mobile as well. And in networking, again, another application space we play in today. In networking, you need very high performance, and this is something we have. You also need scalability, coherency, large core counts. SiFive is able to address all these requirements, and we're able to do so better than the competition. Okay, so 4 market spaces we're targeting. Now let's talk about the products. So in November, we launched the P670 and P470 products. So P670 is our 2023 flagship core. This is a 4-wide out-of-order processor with 2 128-bit vector engines. In addition to the vector support, we also support vector crypto instructions to accelerate functions like AES and SHA-512. Additionally, we have the SiFive Performance P470, and this is our efficiency processor. And this is a very special processor because with the P470, we have very, very good performance, but at the same time, very efficient. And this is an area that we think we're differentiating from ARM and some of the processors that we talked about earlier in the Cortex-A53 and 55. So with the P470, this is a 3-wide out-of-order core. And again, out-of-order is one of the reasons why we think we have so much better performance than the competition out there. But the P470 is also feature set aligned with the P670. So supports the same instruction set. We also have the same vector compute capabilities with 1 vector pipeline instead of 2 in the P670, as well as vector crypto support. Now also, one unique thing SiFive has is we also have non-vector versions of these cores in the P650 and the P450. So you can see the performance points here. So P670 is about 12.5 SPECint 2K6 per gigahertz. And you don't have to worry what that means. I'll tie this back to some processors that you might be familiar with. But P470 being 8 greater than 8 spec-int 2K6 per gigahertz is significantly higher performance than something like the Cortex A55 or even the A510. Now, in addition to having great performance and great power, we also have a lot of new features and capabilities in this product, and you can see this on the top left of the slide. So we're first to market with a lot of these capabilities in the RISC-V space, and some of these are hypervisor support, virtualization support. So hypervisor has been supported in SiFive processors for about a year now, so that continues to carry forward with these new processors. But what is new here is that we now have support for things like the IO-MMU, which is a new standard that was specified at the RISC-V International, and actually SiFive participated in defining that standard. So we now have products based on the new IO-MMU standard. And then we have a new interrupt controller that implements the advanced interrupt architecture. Again, a new standard that was defined at RISC-V International, and SiFive being one of the first to have products with support for this new standard. So what's great about the new interrupt controller is that it allows for better support for virtualization. So interrupts can now be targeted directly to guest operating systems, saving time from trapping to things like a hypervisor. The new interrupt architecture also brings better support for things like message signaled interrupts. That's very common in PCI Express and in networking type applications. Additionally, we support WorldGuard, which is our system security solution, because security is absolutely critical in a lot of the markets that we're targeting here. And then finally, RVA22. So that's the application processor profile as specified by RISC-V International. And this is very important, so I want to spend some time on it. So one of the great things about RISC-V is that it's defined in such a way that the instruction set is very modular. You can add new instructions, you can take instructions away, you can add custom instructions. These things are very good and very useful, especially in the embedded space. And it's one of the reasons why I think you've seen such large adoption of RISC-V in the embedded space, and something that SiFive has supported on our other processors in the portfolio for some time now. However, when you start looking at larger software ecosystems that have software contributed to it from all over, third-party vendors, third-party companies, individuals, open source, it becomes difficult to target different ISAs with different features. It becomes an untractable problem. So what the RISC-V Foundation has done, and what SiFive has also been helping in with one of our founders, Krista Asanovic, is defining a set of ISA profiles that these higher level software ecosystems can target. And RVA22 is going to be the first one of those. So what this does is specify a set of instructions and capabilities that are required by the processor that we think is going to be necessary for base level functionality in application processor ecosystems like Android. And this is important because as long as we implement these standards and as long as the software ecosystem programs to these standards, that means compatibility. And we think standards such as these are important for driving faster adoption of RISC-V in these markets, in markets like Android, like data center. And so in our new lineup of SiFive Performance family processors, we fully support the RVA22 profile. So now let's start taking a look at the processors themselves. So the SiFive Performance P470 is an efficient application processor. It's optimized. One of the reasons, or one of the things that's great about this processor is that it has an out-of-order architecture that enables us to hit fundamentally different performance points compared to some of the competitors out there. And I have direct comparisons after this slide. But just because it's out of order doesn't mean it's not efficient, doesn't mean it's large. In fact, we think we're smaller than the competition that's out there. And again, built on RISC-V, built on the RISC-V ISA, RVA22 compliant, but in addition to RVA22, we support the RISC-V vector extension as well as the vector crypto extension. This is a breakdown of the architecture of the P400 core. It's a 3-wide out-of-order pipeline. And so what that means is we're able to decode, rename, and dispatch 3 instructions at a time. We have a 56 entry reorder buffer. This might sound small, but one of the unique implementation points of our processor is that each entry in our reorder buffer supports up to 7 instructions. So this gives us a significant capabilities in the reorder buffer. If you look on the integer side, we have 3 integer pipelines, 2 ALUs, 1 branch. On load store, we have 1 dedicated load pipe, 1 dedicated store pipe. And then in the P400, we have 1 floating point pipeline and 1 vector pipeline. Remember I said 1 128-bit vector pipeline. And the vector pipeline also has a 128-bit data path as well. Now, if you get the P450, it looks exactly the same, except the vector pipeline is removed from the core. From there, we have a shared L2 cache, but the L2 cache is, a private L2 cache, but the L2 cache is optional in the P400 series. And what we found is a lot of customers, when they start looking at our products, they actually implement this without the L2 cache. And the reason for that is because the performance advantage of the P400 is so large over the ARM efficiency cores that they'd rather just take the area savings and remove the private L2 cache. So outside of the core, from the private L2 cache, we go to a shared L3, and that L3 is shared with all the other cores in the cluster, in the complex. Okay. So that's great, but what does this mean for performance? So P470 is almost twice the performance of Cortex-A55 on a clock-by-clock basis. So running at the same frequency, 2 times the performance. But what we found is that we don't just have an IPC advantage, we also have a significant frequency advantage. And these 2 things compound, right? So that's how we get to 2.75 times the performance of Cortex-A55. But at the same time, with the same implementation, if we compare area with the closest area comparisons we find, right? We don't have access to the ARM processors or the ARM RTL, but there are many analyst reports that tear these things down, and we look at those, and as best as we can tell, we're still 30% lower area. So 2.75 the performance while being 30% smaller, and you get to this 4x compute density. And this is very important. And Jack touched on compute density, but 4x compute density is a big number, right? And what we found is when engaging with customers, it's very difficult to get them to switch or convince them to switch for something like 20% performance gains, 30% performance gains. But when you can give them 4 times the compute density advantage, that's a big number and that's meaningful. And that starts to grab a lot of attention. So you can see why people like Google are starting to get pressure to port Android to RISC-V. The advantage is compelling. So compute density gives you a lot of options, right? One, you can just take the straight cost advantage. Smaller silicon area translates directly into cost. But you can also get increased performance. You can implement more cores in the same area, right? Or you can have some mix of both, right? Where you have higher performance, you have more cores, but perhaps the area advantage was significant enough or the performance advantage was significant enough that you still get great advantages there. Okay, so now let's look at the P670. So the P670 is our highest performance product for 2023. But again, we're focused on performance efficiency and compute density. So making the right trade-offs for performance while maintaining good efficiency, good area. Feature-wise, it implements the same features that we talked about in the P470. So these two products are ISA compatible. So if we look at the architecture here, it looks very similar, right? There's a lot of functions that are similar to the P470, but you'll notice some of the structures and the queues are increased, right? We go from 56 reorder entry buffer to 160 entry buffer. And the whole point of this is to feed the wider pipeline behind it. We also go from one floating point pipeline to two floating point pipelines. We go from one vector ALU to two vector ALUs. So very similar pipeline, but scaled up, and again, scaled up smartly while maintaining good performance, good efficiency. And again, these cores are our second generation out-of-order processor. So we've done this before. We've been designing these. It's taped out. It's in silicon. Now we have the P400 and the P600 as our second generation out-of-order processor. So if we look at the comparison point for P670, the comparison is to A78, Cortex A78. Now here, we're not claiming to be higher performance than Cortex A78. In fact, the chart says about 5% less, but because I'm the marketing guy, I get to say it's about the same. But what is interesting here is that we think we're half the area. And again, this is looking at industry reports that are tearing down Cortex A78 devices, and we're comparing as close as one that we can find to the P670 core. Again, so same performance, half the area. That leads to 2 times the compute density. So again, another significant compute density advantage. So the SiFive Performance portfolio is the broadest RISC-V application processor portfolio. We have multiple design points, and we've been doing this for 2.5 years in the application processor space, and even longer if you go back to some of our cores in the Essential family that support application processors in the Essential family. We're first to market with new RISC-V standards, right? If you look at the IOMMU, the new interrupt controller, the virtualization support that we have, we're first to market with these. And we think this is opening up new market opportunities, right? So I talked about wearables. That's very exciting for us. There's also other consumer applications like DTV that are also very exciting for SiFive. And we think we have great products that fit those applications. And we'll continue to innovate, right? We're not stopping here. We have new products on the roadmap, and we'll continue adding not just new processors, but new capabilities as well. So upgrade to the SiFive Performance family. These cores are available now, right? They're already shipping to lead partners. In fact, these cores are about to be taped out. So these cores are going into the market. We're ready. We're ready to engage. Talk to the local team here. We're happy to show you what we have. And then real quick, before we move on, you know, we talked about having the broadest RISC-V IP portfolio. So we want to talk about that a little bit. So we talked about the SiFive Performance family throughout this presentation. We have 3 other families as well. The SiFive Automotive family, the SiFive Intelligence family, and the Essential family. So the Automotive family, and Jack touched on this, it's a new family that we also launched last year. And what we're doing is looking at leveraging existing successful IP products that we already have and making them suitable for automotive markets. So adding the necessary redundancies and features and capabilities and so on that are needed to meet specific automotive requirements. SiFive Intelligence, I won't say too much on this because I think Johor will talk a little bit more about that in the next presentation. And then finally, SiFive Essential. So this is the classic portfolio of SiFive processors, and I think the one that I talked about 3 years ago when I was in Taiwan. But in the SiFive Essential family, we do have updates since then. So one being the 6 series, which was a new mid-range lineup of processors that we launched about 1 year and 3 months ago. But within the Essential family, we have which you can consider 3 microarchitectures. So the 2 series, which is our smallest and most efficient architecture, the 6 series, which is our mid-range, and the 7 series, which is our high-end embedded architecture. And then within those families, we have 3 different product types. So E7 is a 32-bit embedded processor, S7 is a 64-bit embedded processor, and then U7 is a 64-bit application class processor. So we have the same 3 families in the 6 series, and in the 2 series, we have the 2 embedded variants. Now, what's great about the Essential family is that they do leverage the configurability and extensibility of RISC-V, whereby you can implement different instruction sets. You can add instructions, take instructions away. You can configure the L1, L2 memory subsystem to meet embedded requirements. Because embedded, every gate counts, every milliwatt counts, and customers really like to tune these products to meet their application requirements. Okay, I think there's a break that's coming up after this talk. I do want to direct you to our sponsors in the back. If you haven't visited them, please do. So we have IAR, who have embedded development tools, compilers, programming tools. We also have Green Hills, also embedded development tools, compilers, JTAG probes, operating systems. Microchip, who's been a long partner of SiFive. I think we have PolarFire SoC in the back, which was exciting because it's one of the first big design wins that we had at SiFive and one of the first things I worked on when I started at SiFive. So we have example silicon of SiFive application processors in the house. And then finally, MicroTime, who is a local Taiwanese embedded distributor. So you can buy your tools and probes from these guys. So with that, thank you very much. And I look forward to talking to you again this afternoon.